questions? Okay, so next we'll go to our next topic, chapter is on articulations or joints. So the definition of an articulation is where two or more bones meet. A joint is where two or more bones meet. Okay? So, what are some functions of joints? Movable, right? So because of these we are able to move. But also attaches bones to other bones, right? So holds the skeleton together, but also provides mobility, right? So next we're going to talk about classifications of joints. So the first one is functional classification. This will be into three. Okay. The second one is structural. I'm going to use the other screen for the third one. Here, in some room. So, functional classification is based on how much movement the joint allows. Okay? The functional classification is based on how much movement it allows. So, not all joints allow movement. Okay? Let's look at our cranial bones. We talked about in lab today that cranial bones are joined together by what are those structures? Sutures. In adults, do we want our cranial bones to move? No. Okay, that's an example of where joints do not allow any movement. Okay, that's going to be called synarthrosis. Singular ES. Okay? This does not allow any movement. Okay, our example is we have sutures that hold our cranial bones together. They do not allow the bones to move. Let me do the opposite end first, which are considered freely movable are diarthrosis. And when we talk about freely movable, anything over 15 degrees of movement is considered free. Okay? While only allows some movement, slight movement, is amphiarthrosis. Most of our limb joints are diarthrosis, allows significant free movement. Okay? So synarthrosis, immovable joints. The opposite scale is diarthrosis, freely movable, while amphiarthrosis allows some movements. Okay. Look at a couple, especially in we can look at, for example, fibrocartilaginous bones, right? Between each vertebrae, they only allow a little bit of movement. We are able to double over, which would be considered a pretty large movement. That's because of all the joints. So each joint only is allowing little movement. Okay? That would be a good example of an amphiarthrosis. We'll look at some others too. Okay? Any questions on this? So freely movable, no movement, immovable, slight. So we'll do examples, we'll use those terms to match up with different types of joints. So in terms of structural, it's what's making the joint, right? And if there is a caveat. So the first one is going to be a fibrous joint. Second one is cartilaginous. I'm going to put number 1, number 2, cartilaginous. Okay, and number 3, let's talk about fibrous joints. We have 3 types of fibrous joints. We have sutures that we mentioned earlier or talked about in lab. Okay, those are between cranial bones. Okay, I'm going to use BW between cranial bones. That's a good spot. How much movement will they allow? Immovable. So what are they called? Synostosis. Next one, again, I forget which order I put it, but we will go with this one. This is the next easier one. Gomphosis. Okay. So I'm going to tell you whereabouts it is. Just use that, but it's not really that spot. So it's near the gums. Okay, it's not the gums. It's within the teeth socket itself. It holds the tooth. Tooth, because of its mineralization, because of its calcium, we can think of it like a bone. Okay, so that's sitting in our bone. It's held in place. Okay, so it's within teeth sockets. They're called periodontal ligaments. How much movement would they allow? Do we want to have wobbly teeth? No, we don't want teeth to move at all. Okay? So these are synostosis.
Do they change like when you were doing?
So yes and no. So yes, we do lose those ligaments, those attachments, and then the teeth. Okay, so there's something happened to our gomphosis joint. As we age too, it does, or if we have bad, poor hygiene or something happens to our teeth sockets, we can lose the tooth too. Okay, but that means that joint was broken down, just like any other joint that has. Okay. The third one is syndesmosis. This is the one students kind of forget because there's no easy way for me to relate this to errors. Okay. There's 2 places. So between diaphysis of radius and ulna. Okay, and then distal tibial tibular. What is diaphysis? Shaft of the long bones, where our radius and ulna, and our forearm. So these ones, I know this one's a little bit tougher maybe to picture, and especially the movement part. So they're basically connecting the radius and ulna by fibers. Okay, so this joint itself only allows little movement. But there's another joint which is why we're able to move this way, so it's significant, but it's not because of this joint alone. Okay, there's another joint here which allows us to do it. This joint itself only does a few degrees of movement. So this is, if it allows only a little bit of movement, what is it going to be called? Amphiarthrosis. Sutures, we know, sorry. Gomphosis, it's within IS singular, ES plural. Okay. Ligaments, they're called periodontal ligaments. If you remember periodontist, right? That's the person who looks after, not looks after, it specializes in mouths. Then syndesmosis has 2 places. This interosseous membrane is that fibrous connective tissue that's formed between the diaphysis and diaphysis of radius So where is distal tibiofibular fluid? At the wrist, at the ankle, right? Again, here there are multiple joints, which is why we're able to do that movement, but just by itself it only allows few degrees of movement. So it's empty of control. Okay? So next is the cartilaginous joints. We have two types of cartilaginous joints. They are different two ways. Type of cartilage and the amount of movement they allow. The color can I use? Different color. So it's synchondrosis, ES plural, IS singular, and symphysis, again IS. Let's start with this one. Have we heard of a term or a phrase with this similar sounding name?
Pubic symphysis.
Pubic symphysis. What type of cartilage is that? Yes, here, Highland. It's fibrocartilage. So this one is fibrocartilage. What are the three places we can find fibrocartilage? One is the pubic symphysis. What are the other two? The intervertebral discs. And then what's the other place? Meniscus. So meniscus is not a joint, it's within joints. The other two are joints. Those are examples of symphysis. Okay? How much movement do they allow? A little movement. Okay? Use a different color. These are amphiarthrosis. And we talk about the two, right? So we have pubic symphysis. Here it's only one, so it's IS. And then intervertebral discs. Sorry, I squeeze it. So synchondrosis is made up of hyaline cartilage and does not allow any movement. And the only place we have one is our first rib and sternum. Okay? How many ribs are attached to the sternum? 7 by itself and 3 others also, right? The others, what's the definition of a synarthrosis joint? No movement. The others do move. The joint space or the distance between the bones do change when we take a deep breath in versus while the first one does not. The distance does not change. So that's the only place where the two bones are connected. First rib and manubrium, that's the top part of the sternum. First rib and sternum. That's the only place we have synchondrosis. If you ask me, what about the others? There's no need for it. Made up of cartilage, it's hyaline cartilage, but they move. I guess they wanted to show not only are they different by the type of cartilage, they're also different by the amount. So, synchondrosis is made up of hyaline cartilage, but it does not have any movement. So, when the sternum moves, the rib moves with it. There's no change in distance between the first and the sternum. Right? Whereas the others, there is changes. Right side is here. And symphysis joints, the bones are connected by fibrocartilage. They allow some movement. So to out of 3 spots, 2 of them are joints directly into the third one is not a joint, it's actually inside our knee joint, which we'll talk about what type of joint that is. Any questions so far? Here is a little bit of memorization. So now let's talk about synovial joint. So basically the definition of synovial joint is one that has a cavity between the two joints. Okay? It's not an empty air-filled cavity, it's a fluid-filled cavity, but there is a space between them. Okay? They are all diarthrotic. What does that mean? Yeah, they are freely movable joints. Most of our limb joints are synovial joints. Okay. Let's first talk about what defines a synovial joint. There's 6 features, okay? What define each one, there's some distinguished features. Again, I'll go with the order, I'll talk about it. So first is between the 2 bones, right? There is hyaline cartilage that's protecting the ends of the bones. Okay, articular cartilage. Next, again, I forget which order, we're going to have a capsule that surrounds. So if this is a 2D picture, again, I'm just going to draw it as a rectangle just to be easier to show. Right? This capsule around again 3-dimensional, right? That will form the back as 2. Okay. Then 3 would be the cavity inside. With fluid is the 4th one. Okay. And then ligaments, and we'll talk about blood vessels. So, articular capsule is next. In that we need to distinguish. We talk about how synovial membrane or synovial is a part of our epithelium, right? So inside we have the synovial membrane that will produce the synovium. Outside is a little bit more tougher, it's going to hold this cavity in place. That's fibrous. What's the advantage or functional significance of dense, irregular connective tissue? Strain in multiple directions, right? Absorb strain in multiple directions. Which one absorbs strain in one direction? Dense regular. Where can we find dense regular connective tissue? And there's the ligaments. So this way, if there's stress, they can still absorb some of this. And next one is the cavity. That's the space. Okay. In this space, we have fluid. Okay, that's going to be our fluid. Okay, synovial fluid produced by the synovial membrane, which is part of the capsule, right? Basically, synovial fluid is a filtrate of blood, but there's some additional stuff. We do have some hyaluronic acid in there, which helps to lubricate it better. It also has phagocytes, so it's not just blood plasma, because in our joints, we want them to be aseptic compared to septic. What's the difference? Yes and no. Not sick and not sick is not, like one is something, yeah. It's to do with is that bacteria. Sepsis is when bacteria gets or microorganisms get into our blood, right? Spread around septicemia. Right? Aseptic we don't want. So when we are in operating theater, operating room theater is used in England, sorry. We want it aseptic. Okay, so we want aseptic conditions for it. So here we do not want any bacteria. Lots of other places we have normal flora, normal bacteria, but here we do not. Okay? So they have these cells that remove that as well. Then the 5th one is ligaments. That's going to connect. What's the difference between ligaments and tendons? They're both made of dense regular connective tissue. Yeah, which one connects muscle to bone? Tendons, right? Ligaments connect bone to bone. So here, the ligaments will connect this bone to the next one. The last one is nerves and blood supply. So we have good blood supply means if you ever injured your joints, you would have felt pain, you may have flooded with blood. That's easily, it does have a lot of blood supply. Okay? Let's talk about the 6 different types of, and other things that may have, by the way. So menisci, we talked about, mentioned, what kind of cartilage is menisci made of? Fibrocartilage. How many do we have in each knee? 2 meniscus. We'll talk about this on Monday. We'll talk about the lateral meniscus and the medial meniscus, basically the way that we go. Okay? In 4 big joints, we have what's called fatty pads. What do you think it's a collection of? Adipose connective tissue. Why might it be present here? Yes, not in this case. It's to do with the cushioning, where we have fat around organs. It's to help absorb some of that strain. So our big 4, shoulders, elbows, hips, and knees do have again bones. Chicken you can see between thigh bone and the basically tibia to the drumstick. You will see some fat in there as well. Okay. Ligaments that can be found inside the capsule or outside, so extra can take out. But again, this is part of our synovial joint population. Bursa, this is something that's found outside of the joint. Okay, bursa is a fluid-filled cavity, fluid-filled sac. This fluid is the same synovial fluid. We have again in the big 4 joints, we have a nice bursa here underneath our clavicle. So when our shoulder moves, this absorbs some of the stress that may be experienced on the ligaments or to the tendons, to other bones. They themselves are not in the joints, but they help that joint. Okay? So they are fluid-filled sacs that are found outside of the joint that help with the movement. So, 6 joints, 6 synovial joints. Let me write that. So 1, planar, planar. That's in the same order, hinge. Name also called condylar. So let's start with planar, flat or almost flat bones, meaning at this joint. Okay, so between the carpals, how many carpal bones do we have? 8. So between the carpal bones, there are, it's still synovial joint, which is why we're able to do some movements. That's going to be our planar joints. Here it shows between clavicle, yes, it's actually even better, is between our clavicle and the scapula. That's a nice planar joint. Okay, so flatten those slightly curved. So between the tarsal bones, between carpal bones, between our scapula and clavicle are planar joints. Okay. Tarsals between carpal. How much movement, by the way? If you're paying attention, yeah, these are all diaphragm. Okay. Hinge joint basically allow movement in kind of one direction, right? So our flexion, extension, so our elbows, we do have hinge joints here. Please move here. Interphalangeal joints are hinge joints. These ones are slightly different. Our knee joints are hinge joints. Okay, so between the elbow, at the elbow, it's two bones. It's between ulna and the humerus. Okay, then in the knee, it's gonna be femur and the tibia. Okay, we also have them in these knuckles. Okay, those are also going to be hinge joints, so they only allow in one plane. Pivot joints, we just have two places. Okay, we have a rounded head of one with a kind of circle. It doesn't have to be with the whole bone circle. Okay, it could be a ligament that completes the circle. That way, the one bone just rotates about that axis. That's a pivotal. Yeah, it's on our head. It's the first bone, first cervical bone. What was the name of that first cervical bone? Atlas. And the second one? Axis. So between atlas and axis is a pivot joint. Okay. But here it's between the atlas and the occipital bone. That's an example of a hinge joint. Between the atlas and axis is a pivot joint. Between the radius and ulna at the elbow is also a pivot joint, which is why we do this big movement. Okay, that's because of this pivot joint. And again, it doesn't have to be complete circle by the bone. You can have some ligaments that completes the circle around this rounded pointed end of radius ulna, radius and ulna is the proximal. Radius ulna, and between the atlas. In terms of ellipsoidal, these are also called condyloid. That's the knuckle here. So they can have circular movements. Okay, they are, I consider them like a smaller version of our ball and socket. Okay, there's a rounded head and a concave surface that helps round rotational movement. So this is because of a ellipsoidal. Another name is converge. You also have it here between the carpals and the radius. That's why we do all of that. Saddle joint, we only have one in our bone. Okay? It's at the base of the thumb. At the base of the thumb is our saddle joint. So when you do this movement, if you try doing the same movement for our index finger as our thumb, what happens? Is it smooth? No, it jumps, right? So it's here that it jumps. It goes between the metacarpal and the first carpal. Okay, that's a saddle joint. That's the only place where a saddle joint is quite does this jumping. It doesn't go smooth. It's like a horse, horse saddle. So carpal, metacarpal joint. The last one is ball and socket. Where do we have ball and socket? Shoulder between what two bones? Humerus and the scapula. Good. And then the femur and the which bone first? Yep, head of the femur and the hip bone or the acid album. Those are the two bone sockets. Rounded head with a concave surface. It allows again multi-angle questions. Yeah, have a lot of time. We finish this time. Okay, so challenges. Any questions about chapters 1, 2, 3, and 5, which is going to be our lectures. When an atom loses electrons, what charge does it become?
Positive.
Positive. Why is it positive? It lost something.
So lost a negative
Lost
charge.
an electron, so it's more. What's the charge of an electron? Negative. What's the positively charged subatomic particle in our atoms?
Protons.
How much mass do protons have?
1 AMU.
1. Right. What else has mass in our subatomic particles?
Neutrons.
What are covalent bonds?
When they're sharing electrons.
Sharing of electrons. Ionic bonds?
Giving and taking.
One gives, one takes.
Lessons.
Plus.
Lessons.
Monomers of proteins are? Monomers of proteins, amino acids, monomer of nucleic acids. Right. Monomer of carbohydrates. Right. Polymer of carbohydrates. Polysaccharide. Polymer of proteins. That's the monomer. Polysaccharide. In terms of cell, where does DNA replication take place in the cell cycle? Be specific as possible. In the interface, what phase of interface? What subphase of interface?
Is it the S phase?
S phase, right? Is that the first phase of interface? What's the first phase of interface called? G1. What's next? S. At what phase does the chromosomes split and fill? Right, the two chromatids, those two DNA molecules are split. Difference. What does rough ER do with function? Proteins and smooth ER, two functions again. Detoxifies and other lipids, right? Including steroids, hormones are produced as well. What's the difference between chromosome and chromatin?
Chromosomes are the condensed form.
Highly condensed form, less condensed form, without chromatin. Still condensed, right? Because it's normally we stretch out the longest DNA molecule is about 6 feet long. So it's packaged in the cell. Yeah, please do look over tissues because it's easy to mix them up. Simple columnar epithelium, where can we find them? Simple columnar.
Lining of the stomach of the rectum.
Large and lining of stomach through all the way to rectum. Where else? Not the kidney tubules, but simple columnar. The fallopian tubes, the small bronchi. What's in the large bronchi? Lining of large bronchi. Pseudostratified columnar epithelium. Where can we find simple cuboidal epithelium? That's the kidney. Right. Glands. The surface of ovaries. Stratified squamous epithelium. What's the functional significance of stratified squamous epithelium? Yeah, that's the underlying layers skin breach. Functional significance of simple squamous epithelium? diffusion and filtration. And absorption, secretion of the yellow cube oil, column now, we do that. Filtration and diffusion for us, so show the distance. Regular revised already. Areola connective tissue,
Triglycerides.
right? Salt and water there. Which one stores triglycerides?
Adipose.
What are the 4 different types of tissues? Nervous tissue, muscular, connective, epithelial. Nervous tissue, which group of cells will transmit nerve impulses? What are the ones do not transmit nerve impulses? Neuroglial cells or glial cells, or we also see glia, neuroglia. What are the 3 components of connective tissues? Fibers, ground substance, and ground substance are extracellular. What are the 3 types of fibers? Elastic, reticular, collagen. Which can absorb the most amount of stress? Collagen. Elastic is not, it's too much. Yeah, collagen is the best. Wherever we need that. So for example, in dense regular connective tissues, mostly collagen. You all think of any questions you want to use that? I did not revise chapter 1, but please do go over chapter 1 so you want to know homeostasis, you want to know directional terms, regional terms, difference between positive feedback and negative feedback, difference between anatomy and physiology. What's positive feedback? Why is that happening? What does it do? Yeah, so that makes it all movements and it increases that change, right? But negative feedback, there is no direction of that change. It goes up, for example, calcium. Calcium is low, we will release thyroid hormones which will try to raise that calcium back. Our region. So what is the right side upper region of our abdomen? Right, hypochondriac, just below that. Right lumbar, below that. Right inguinal or iliac fossa is what they say, but inguinal is the correct term. In the middle, top. The gastric below that. Below that. What's transverse plane? Superior part. What's the one that divides into the left and right part? What's the other one called? Frontal is the whole body flow is just split. But yeah, it's in the same zone. Where protons found? Nucleus of the atom. What else is found in the nucleus? Neutrons. Where are electrons found? Shells. How many in the first shell? 2. Maximum of 2. Next shell? 8. Maximum of 8. It just keeps reading from inside out, outside in. Inside out. Right. Keeps going. It needs to go third. We can fill up 18, but the ones we will look at, how much will it fill to? 8. We'll only look at calcium, the biggest one. What are Groups in a periodic table. How do you find groups? Not what they are mean. They are the columns, so elements and groups are in columns. What do elements in a group have in common? So valence, the number of electrons in valence shell. What is a valence shell? Why is that significant in conversation? Bonding, whether they want to lose electrons, gain electrons, or want to share electrons. What number do they want to get to? 8, right? Except for first shell, which wants to get to? Yes. For example, if you look at lithium, it's 2, 1, it just loses at 1, gets to 2, that's 3 elements. How is oxygen molecule bonded? How many electrons does oxygen need to get? Again, you don't have to memorize it. You want to remember it. No. Give you a table. You will get 8 total. So how many in the valence shell? 6. So what does it want to do? Gain 2, so it can share 2 and oxygen 4. It's just a total. What is hydrogen gas? How does hydrogen gas form? Hydrogen gas. H2 shares how many? Just one. It needs 2 to finish. What about nitrogen gas? Shares 3 because it's in the fifth group, so it needs 3 more. Right, so it shares 3. What's a polar for this?
When they're not shared equally.
Yeah, unequal sharing is polar. When they're shared equally, they are non-polar. Oxygen gas, polar or non-polar?
Not really.
Non-polar, because both oxygens, will they have either one have a stronger pull? Water?
Oh.
Polar, right? Oxygen has a stronger pull than hydrogen. What is hydrogen bonds? The same molecule? That's a partially linked cell. One molecule attracted by a partially polar cell. Question? We talked about acids and bases too. We did. What does acids form? They give off H plus ions. What about bases? They will take it or produce OH minus. Right, now, pH scale. If I have a higher pH scale, what about the H plus ion concentration?
Lower.
Lower pH is about H plus ion concentration. Acids will be having a high number pH number or lower pH?
Lower.
It's acids less than 7, more than 7 is acids. What are phosphorus? We'll talk about more into the blood. We'll talk about how we do our bicarbonate, phosphorus, phosphorus can really prevent heart disease. Questions? So maximum 50, but I'm leaning towards a little less because usually I have roughly about 2/3 in multiple choice short answer matching questions, 1/3 written. So 1/3 written could be anything like could you draw the Bohr model for an element, for example, or it could be what's the functional significance of stratified swarm or something. So it won't be big, huge writings, but it will take time. So depending on how many and how long it will take, how much fall short, one word for one. Short sentences. Have a wonderful